Okay, this is AGEC 305 Lab 7. This is our Week 10 lab, and this replaces our Friday class. So we are learning, this lab is focused on a new technique for equilibrium problems. It's a little complicated, but it's pretty easy to set up in a spreadsheet, and of course, the goal here is we've spent a lot of time looking at supply and demand relationships in a single market setting. We've added some policy variables and policy equations, and those problems are starting to get big. The substitution method that we use for solving them algebraically takes more steps now, and the results that we get algebraically this week, right? In lecture this week, I was telling you they're not as satisfying. They don't have these kind of clean ratios or simple sort of comparisons that we can make and say this is an equation that gives you an easy way of doing price analysis. So our technique now moves to building the model in a spreadsheet, solving the quantitative results, and then doing sensitivity or doing changes to some of the parameters and confirming our intuition. So we make some changes to the supplier demand parameters and then see how the prices adjust and see how the producer versus consumer price changes, and we get the same sort of effect that we were looking for in those algebraic solutions. And this will be important as we move to multiple markets, because we can't solve those problems. There are a lot of parameters. We can solve them. We could do the same thing, but the results you get are fairly complicated to look at, and this becomes a simpler way. It's more of a simulation and trying to look at the impacts in that regard. So let's proceed here. Okay, we have a parametric supply and demand system. By parametric, I mean I haven't replaced A, B, C, and D with numbers. I've left those in. And we have some policy variables. So this is a little different than what we had in the handout in class 10.1, the first lecture this week. I haven't done any substitution. So we have a supply equation that's the quantity supplied depends on the producer price. The quantity demanded depends on the consumer price. Those two equations are tied together by the market clearing equation, so the supply quantity and demand quantity have to match up. There's a price linkage equation that says if there's a gap between the consumer and the producer price, we're going to call it a subsidy. And you'll notice that I've left out the possibility of a tax. That's going to be something we see in a little bit, why we have to do that. If we want to use this technique that we're talking about today, then we have to live with the fact that we only get one policy variable here, a subsidy, or we could call it a tax, and we can't constrain S to be larger than or equal to 0 in this solution technique. And then the final piece in this one, if I want to write the producer price here and here, then I need to make a declaration at the end that says the producer price is going to be equal to some price floor. And so this is another change from what we did the other day. And in this case, the issue is, the potential issue is that the producer price at equilibrium could try to be higher than the price floor, right? If the market price that results from this solution, from the market clearing solution, is larger than the price floor, then if we write the equation this way, then what we'll see is the producer price gets reduced. It gets lowered. Instead of being a price floor, it becomes a price ceiling. And so that's the sort of trade-off we have to make to be able to do these. So we're going to have to pay attention to our solution and recognize when we might have to make a change to the setup to be able to think about this problem. So this week we're learning this technique, the matrix technique. Next week we'll learn an additional technique using Solver, using a different tool in that lab that lets us deal with that lets us handle the inequalities. But for now we have to deal with it this way. So we have our 5 equations. Let's proceed and see if we can learn a little bit about this technique. The first thing to do when we're going to set a problem up like this is to think carefully about what's endogenous and what's exogenous. So endogenous means it's something we're going to solve for. Exogenous means it's something that we've been given. So the task in setting up these models is to use some economic logic, right? So what things in a market do we expect to recover or to understand or to see emerge as part of the balance that happens in a market between the supply and demand forces, and which things are sort of given from the outside of the market. Those would be the policy parameters, the policy restrictions that exist. The other thing would be the actual supply and demand drivers, right? The intercept and the slope. And then the final thing would be shifts, right? So shifts to supply and demand, those happen from outside the market. The other thing would be algebraic limitations, and so that's what we were talking about back here. So there's the way we write these equations. If we're going to solve the model using this matrix technique, gives us a limitation on the way we can write our equations. So this is just a reminder. In the class handout, I substituted directly, the class handout from Monday, I substituted directly for the producer price. Here I put that equation in because the benefit of doing these matrix problems is you can add as many equations you want as long as you have the right number of a balance between the number of variables and the number of equations, or the number of unknown variables or endogenous variables, then everything will work out. And so we have 5 endogenous variables for these 5 equations that we had back on slide 1. Okay, so there's 5 equations written there. That means we need 5 variables to be solved for. We have the 2 quantities, the 2 prices, and then the subsidy level that sits between the 2 prices. So we have 4 basic economic outcomes, 2 for the supply side, 2 for the demand side, and then we have this policy variable. And that'll be what we see in our model. Okay, so we have to get this equation system, these 5 equations, set up in a way that that we can use the matrix technique. Okay, so it's complicated. There are whole classes taught on matrix algebra. I am just giving you the simple rules to follow that we have for this class. And I should point out now that this is not something I would expect us to do or be tested on extensively. The point of teaching this is we're going to get more complicated models, and the spreadsheets I'm going to give you to do the analysis of multiple markets are going to include a matrix setup, and you'll need to be able to look at that matrix setup and sort of read back what the equations are. You'll need to be able to understand why the matrix that I've put in a spreadsheet matches up to the equation that you were given. Okay, so our rules here basically are separate the endogenous pieces from the exogenous pieces. So if it's a term in the equation, and by term we mean something that sits between a subtraction or an addition sign, so going back here, QS is a term, A is a term, and then B times the producer price is a term. QD is a term, C is a term, D times the consumer price is a term. So everything that is, every additive term, right, everything that's added or subtracted is its own term, and that's how we want to separate this stuff. So our rules: move all terms with an endogenous component. So if it includes an endogenous variable, it goes on the left-hand side of the equation. If it does not have an endogenous component, if everything is exogenous, move it to the right-hand side. And so that leaves us with equations that look like this. The quantity supplied minus the slope times the producer price is equal to the intercept, right? So we have the exogenous piece from the equation sitting over here by itself, QS minus B times P, QD minus D times P, and that'll be equal to the intercept. Some of these equations don't have any endogenous pieces. The market clearing equation is just QS is equal to QD, and in the matrix format, those are both endogenous variables. They both need to be on the left-hand side, so we say that the quantity supplied minus the quantity demanded has to be equal to 0. There's nothing on the right-hand side. And the same thing for the price linkage equation. So now it's move the producer price and subsidy from the right-hand side to the left-hand side so that consumer price minus the producer price plus the subsidy has to balance out to be equal to 0. So this is just another way of writing equations. And then finally, down here in this policy equation, we're saying the producer price needs to be equal to this exogenously given price floor or target price. Okay, and so you'll see why, even though we call it price floor in the class and the way we're talking about the policy, the way it's written here as an equation makes it more of a target price. It's always going to be the producer price will always be bound to whatever you set that target price to. Okay, so that's step one. Step one is converting everything to this format: endogenous, exogenous. Step two means writing the equations as though every endogenous variable is in every equation. Okay, and so what does that mean? We need a cell. We need a place in every in the matrix. We need a place for every endogenous variable. Okay, so if the variable doesn't appear in the equation the way we've written it here, for instance, the consumer price and the quantity demanded and the subsidy level, none of those are in this first equation, but we need to be able to pretend they are, or fill in as though they are in the matrix that we are going to build here. And so the way to do that is just to put in a coefficient that is 0 for all of the variables that are not part of this equation. And so the way that makes it, the way it ends up looking is like this. So 1 times the quantity supplied plus 0 times the quantity demanded, because that is not part of the supply equation, minus B, that's the slope, times the producer price, and then we end up with 0 times the consumer price and 0 times the subsidy. So the matrix pieces are really these coefficients: 1, 0, minus B, 0, and 0. And so, you know, a matrix is this sort of lattice or this cell-by-cell framework, and we need to understand the contributions of every endogenous variable to every equation, and the contributions here are 0, 0, and 0, and so those need to be included. That's one of the things that lets us solve this quite simply, is being able to write these things in this sort of coefficients matrix approach. There is a handout, and for those of you that have better luck reading through the steps than trying to follow along in a lecture format, this is a good time to read up to the part where the A matrix is written and try to see if you can understand that as well. These clip outs, these clips or snips, I guess, come from the handout for this week. When we build this equation or rewrite this equation this way with zeros in front of all the variables that are not included, we are building out what we call the coefficients matrix, or what's going to be called the A matrix in matrix algebra terms. Okay, and so this is the lattice or the structure of this A matrix, this coefficients matrix. We're going to use a column for each variable, right, so we can put those in as headings, and then we need a row for each equation. Okay, and so I guess that should say each endogenous variable. So these are the things that we have to solve for. They come, they come out of the system as a solution piece. And so we have these columns like this, and the equations over here defining the rows. And of course, this thing is what we call a square matrix. It has 5 columns and 5 rows, and that old condition that you have always had, that you've known, you need one equation for each unknown, or for each unknown variable. It comes from this, right? This matrix techniques can be shown to prove that holds up no matter how big the system gets. The one-for-one condition is generic. It doesn't matter how big the problem gets. And so what we do is fill in this A matrix, or this coefficients matrix, with the pieces from the rewritten supply equations. So the first row in that matrix, that A matrix, is going to be 1, 0, minus B, 0, and 0. And so we can fill those in right here. So starting with equation 1, which is the supply equation, we get a 1 for the quantity supplied, 0 for quantity demanded, minus 1, or minus B, I guess, for the supply slope, and that's because that got moved to the left-hand side of that equation. 0 here and 0 here. Okay, the completed A matrix for this problem in table form looks like this. Okay, so remember, we have moved all the endogenous variables to the left-hand side, so that's why the B coefficient and the D coefficient now have negative signs, because they had to be moved from the right-hand side of an equation to the left-hand side of an equation. And we could read these equations off directly to some degree, right? So this is saying 1 times the quantity supplied minus B times the producer price, and then it's going to be equal to something, right? And then that's what is going on down here. But if you fill all these in, the equation 1 is the supply equation, equation 2 is the demand equation, equation 3 is market clearing, equation 4 is the price linkage, right? So it's the price linkage, so it's going to have a coefficient for the producer price, a coefficient for the consumer price, and a coefficient for the subsidy. And then finally, equation 5 is just that policy equation, and the only thing on the left-hand side of that equation was the producer price, right? So it ends up with a 1 and a bunch of zeros. Okay, so when we have this kind of matrix, get this piece, the coefficient matrix, done, we're essentially home free. So if we can get all the steps built right here correctly, and of course in an Excel spreadsheet, instead of putting negative B or negative D, we will put a cell reference that takes us to the supply slope and the demand slope, right? And that means that we will have a matrix that changes every time we change some assumption about how supply responds to prices and how demand responds to prices. Okay, so if this is the A matrix, or the coefficients matrix, then we could rewrite this as an equation. This is a special kind of an equation, a matrix equation. But it says the coefficients matrix multiplied by x, and that's the unknowns. So this bracket x is a matrix, or some, the best term is a vector, but it's a listing of the unknown endogenous variables. And so this coefficients matrix times x has to be equal to all the exogenous pieces that got moved to the right hand side. And so this is the equation we're going to solve using the matrix information and Excel's tools. So we have to build out this B matrix. So if x's are the unknowns, we're not going to know those yet. We have our coefficients matrix, so let's work on the second one, the B matrix. The B matrix is just going to be all that stuff that you put on the right hand side when we rewrote the supply, demand, and other equations. Okay, so everything that got pushed over to the right hand side did not include an endogenous variable, so they don't belong over in the A matrix, where the columns are defined by every endogenous variable. Okay, so the B matrix is just this exogenous information from the right hand side of the system, and if you look, you see that it looked like this. So we had, in the first equation, the supply equation, the intercept got moved to the right hand side. Same thing for the demand equation. We have the intercept C is on the right hand side. Market clearing and the price linkage equations, there's nothing over there, so we just have zeros. And then finally, for the policy equation that says that the producer price is equal to a target price, we have PF. Okay, and then again, so A and C and PF are parameters. Those are things that stand in right now for numbers that we're going to apply. And so when you look in the spreadsheet, you'll see that I've actually replaced the B matrix when it's written in the spreadsheet includes cell references. So this number here corresponds to A, and it's a cell reference that says, if go find the cell of this this spreadsheet that reports the intercept of the supply equation. The second one is linked to the intercept of the demand equation, and then this final one, is linked to the target price. And so that gives us our B matrix. Okay, so now we have the A coefficients matrix, B the exogenous information matrix, and now we have to actually do the algebra. Okay, we're going to let Excel do it, but we should understand the rules and what's going on. So think about your single equation algebra. If I gave you an equation that just said, one single equation that said A times X is equal to B, to solve for X you would either divide both sides, right, by A, or another way of doing that would be to say multiply both sides by 1 divided by A. So 1 over A times X is equal to 1 over A times B, and that would give you a solution because 1 over A times A cancels, and then you end up with just what's on the right hand side, or you could say X is equal to 1 over A times B. And so this is a general rule of algebra. You might remember it. You can invert the coefficient, multiply to eliminate it, and it comes from the identity property. So the identity property says that if you multiply something by its inverse, 1 over A times A, you end up with 1. And when we say we eliminate something, right, or cancel it, it's really saying the solution or the result of this operation right here, 1 over A times A, is 1, and we just don't write it anymore. Okay, and so that identity property just says that you end up with 1 when you do this multiplication. And we have a similar property in matrix operations. So if you write a matrix equation and do an inversion and multiplication of that inversion times its self, then you'll end up with something like 1. Instead of 1, you end up with an identity matrix. But the main point here is you can eliminate that A matrix on the left-hand side of the equation. Okay, so what we're saying here is, if this is A the matrix times X the matrix equals B, then we need to find 1 over A, or the inverse of A, multiply that times A, and we'll eliminate it from the left-hand side of the equation. To be able to do that, we need to also multiply the right-hand side by 1 over A, or that A inverse. But that's going to be the solution technique. And so here it is written out. So if the matrix A times the matrix X is equal to the matrix B, then finding A inverse, multiplying by A times X, can be done as long as we multiply the right hand side B matrix by A inverse, and then we'll get the solution. The solution is this cancels itself out. The identity property takes this away, and we end up with a left hand side that's a vector, or a listing of the solution variables X, and the right hand side is A inverse, the inverse of the A matrix, so the coefficients matrix multiplied by B. Okay, and so here's how it's going to look in the spreadsheet. Again, this is a cell reference right here in the price column. This is a cell reference in the price column. But in the spreadsheet, the first step is just to find that A inverse matrix. So it's not as simple as taking 1 over some values. It's actually quite complex, one of the more tedious things you can do, but Excel does it automatically. So we just write, if we build out our A matrix like this and do it accurately, then we can just use an array formula in Excel called MINVERSE. We can solve it, and cell by cell we'll end up with this 5 by 5 inversion matrix. Okay, I'm not going to even pretend to tell you the steps involved in getting this. There's no way. It takes too many steps to show you how to do it by hand, but I can tell you a few things. If you ever want to check how it works, you could multiply this matrix times this matrix, and you should end up with a 1 on every diagonal and a 0 everywhere else. The other thing is, well, I mean, Excel's not going to make a mistake, so any mistakes that show up will be because we built our coefficient matrix incorrectly. Okay, so so we need this matrix, and that's the one we build. We let Excel solve for this one, to deal with the tediousness, and then we write our problem. Our solution over here is this X, is the X matrix, right? The solution is, how do we get this listing for supply, demand, quantities, producer and consumer prices, and the subsidy level? Well, we know that comes from back here. That listing, the two quantities, the two prices, and the subsidy comes from multiplying A inverse, that coefficient matrix inverse, times B, and that's what this problem, this breakout here is writing. So the A matrix in its inverse form multiplied by the B matrix, this listing of the right hand sides. If you do that multiplication, you end up with this solution. And I'm not going to tell you how to do that either, but if you're curious, it's 1 times this plus 0 times this plus 0 times this plus 0 times this plus 1 times this, and that gives you the first cell. So that's another little tedious operation. Excel's good at the tedious stuff, but we have to be good at setting it up and giving it the right instructions. Okay, so we could follow that through, and you would see that this all works out. And we will. I want to switch to the spreadsheet here in just a second and show you how it works. Okay, just a couple of notes. The value in this technique is it gives us this organized way to look at big systems. So our goal for next week is going to be to look at a commodity market and the land market or some input market at the same time. That means instead of having quantity supplied and demanded for one product, we need it for at least 2 products, and we need market clearing for 2 products, and we are going to have to maintain prices, at least 2 different prices, but as many as 8 supply price and demand price, as many as 4 prices, 2 the producer price and consumer price, or the purchase and sale price for the output market, and the purchase and sale price for the input market. And so if we're going to link up all these prices and start to look at sort of bigger equation systems, we really don't have much choice other than to come up with some organized way of putting all the information down, trying to solve for the solution, and then trying to play around with the simulation and see how changes in one market affect the price in the other. And that's going to be our goal. And then the last piece here, I mentioned a couple times already, you can't have inequalities in this algebraic system, so I can't use that subsidies can only be larger than 0 condition. So if we get a negative subsidy level, then we are actually applying a tax, and we would have to redo our equation system. Okay, so let me jump out to my spreadsheet and show you the spreadsheet that you're going to get. So on the left side of your spreadsheet this week is the same model we've been playing with this week. So you have the supply equation with an intercept and a slope. Okay, so and I'm just going to set it to be 0 and 1 like the example we did on Monday. You have a quantity supplied, which depends on the intercept and slope, so you can go through and verify all these variables. We have a producer price, which is going to be set equal to this producer floor level, okay, this price floor or target price level. On the demand side, we have an intercept and a slope, and then the quantity demanded depends on the consumer price here, and the consumer price is solved for in that price linking equation, right? And so that means take the producer price in C6, subtract off the subsidy level in C15, and you get the consumer price. And so this model here is on the left hand side is set up as a goal seek model. And so I think maybe it was lab 3, maybe it was lab 2. We first solved these things this way, and so the algebra, the setup over here, can be a little complicated, and we might want to change things around. So the easiest way to do this is to use this quantity surplus, or use the market clearing condition, force it to be 0, and use goal seek to solve. And so let me show you how that works. So let's say that instead of the price floor of 60, we decided to set it to 61. Okay, and so what happened there? Well, that introduced an imbalance, and so now there's a quantity supplied is less than quantity demanded, and that's because the subsidy value didn't change. And so the thing for us to do is to reevaluate using goal seek. So we are going to target this to be 0 by changing the subsidy level, and hopefully we'll get the new equilibrium result. So let's go to goal seek. If you go to data and then under what if analysis here, click on goal seek. Okay, so it says set cell, so the target cell is C18. The target value, we just type in 0, and then we're going to use this policy lever, this subsidy variable, here in cell C15 to get the new solution. So you click on OK, it adjusts, and it finds that when you change the price floor to 61, the producer price changes to 61, the quantity supply changes to 61, so does the quantity demanded, and then the consumer price falls to 39. The subsidy value has to go up to 22. Okay, now if you move over to the right here where I have the matrix set up, solution for this problem, let me just point out a few things. So this is this cell right here is set to the supply slope, just like we talked about in the PowerPoint. This cell is set up to the demand slope. This cell is set to be the intercept of supply. This cell is set to be the intercept of demand. And then this cell here is set up to be the price floor. So those are all the parameters here, the first two here, and this one. These are the only things that aren't a 1 or -1 by design, right? So this one happens to be -1 and 1 just because I chose those values for B and D, but they don't have to be. Okay, so I'm not sure what happened there. Okay, so let's Yeah. Okay, so get the cell references correct, and those will only be up here on the A matrix and the B matrix. We need the cell references. Yeah. What else? So let's go down here to the A matrix inverse. I told you that we were going to let Excel solve for the inverse, and that's what we do. The format or the formula is MINVERSE, MINVERSE, and then it takes an array, and so you can see that when I have the Excel function brought up here, it highlights this entire array, and its solution, the inverse solution, is also an array of the same size, and so that's what happens here. So that means if I were going to do this, and I'll risk deleting it here and re-entering the values, so that means we would go MINVERSE, highlight the entire array up here as the input to that cell, and then hit enter, and then what we need to do is highlight all the area that would be part of the new inverse, hit F2 to enter an array formula, and then you hit Control Shift Enter, and it fills everything in. Okay, and so that's an array formula, not too important, because these are going to be set up for you. And then the last piece is just multiply this matrix, the A matrix inverse, times the B matrix, and so that's what's done down here. So when you see this solution is actually the matrix multiplication, or MMULT, and look, when you see the inputs for it, it's array 1 times array 2, or that means matrix 1 times matrix 2 in our terms. So it's multiplying the A matrix inverse from right here times the red B matrix up here, and we get the solution. Okay, so why do I want to do this, or why would I go to the trouble of setting this matrix system up like this? Well, one, we get all the solution variables in a nice, convenient way. If you're wondering how I know which variables go where, it's based off of the order right here. Okay, so QS is first, quantity demanded is second, so that ordering stays the same in the solution. We get all these solution variables, and then I could go back and I could use my formula for P star, which is just the intercept minus the intercept, divide that result by slope minus the slope, and we can get this free market price, right, that happens when there's no subsidy. And then you could do something like subtract the subsidized price, subtract the free market price from the subsidized price to get the gain to producers in price terms. You could subtract from the free market price the price paid by consumers. That gives you the gain to consumers. Then we could take a ratio, the producer to consumer price gains, right, because they get price improvements from these subsidies. And then we had this other when we were working through these problems, we kept getting ratios of B to D, or D to B, and you can see right here that I'm writing this in terms of negative D over B, so some positive ratio of the demand slope to the supply slope, and it happens to be the same as the ratio of the producer gain to the consumer gain. Okay, and so that's why I just tacked that on there at the bottom. Okay, so why do all this jazz, the matrix solution stuff? Well, one, we could write, if you get 7, 8 equations, the setup on this side becomes complicated, and we'll overcome that next week. We'll see another way of doing things that might be easier. But the other is, let's say I want to change that back to 60. Well, if I want to resolve that problem using goal seek, I have to highlight this, go back into the under data, under the what if, and do the goal seek again. But the matrix solution is just a multiplication, right? It's A matrix inverse times B matrix, and it automatically solves for all of this stuff. It does it all on its own. Or if I wanted to come back and check the parameters, what happens if the intercept of the supply equation is now 5? I get the solution over here automatically. I don't have to come back to goal seek and resolve it every time I want to make a change. Everything is automated, and so I get to see all of my results. And then of course the interesting one that you'll do for your quiz this week is just to test out some values for the supply slope. The supply slope and the demand slope. So if I set this to something like 1.1, then we get these results, we get these ratios, but more importantly, oh yeah, everything's right, yeah. Okay, so we get everything that we expect. The subsidy goes up, but the gain to producers relative to consumers is lower because now the supply is more responsive than demand. And so an easy way to reverse that and see if everything holds up and you can change that result is to make demand more responsive than supply. Okay, and so now who gets the bigger share, or who gets more of the subsidy benefit? Well, the consumer subsidy is smaller than the producer subsidy, and it turns out the ratio of those two, the producer subsidy or the producer gain is 10% larger than the consumer gain, while the demand response on the demand side is 10% larger than the supply side. Okay, so these ratios right here will never break no matter what you do in these problems. Okay, so you have this spreadsheet. It is all filled in for you. If you are uncomfortable looking down here and using these results, I do encourage you to go through and check the formulas and see and try to get a feel for this. The main thing to do, and a couple of your quiz questions will ask you, is how do you read these coefficients out? What do they match up to? Right? And so look at this. This is a cell reference to B, right? To the slope. It's a cell reference to B, the slope of the supply equation, but it has a negative sign in front of it, and that's because it's negative, the negative of B, because we had to rewrite the matrix equation to move it to the left-hand side. And so there'll be a couple of quiz questions just on that, on the conversion process. Nothing about Excel or nothing about doing this, but about moving endogenous variables to the left-hand side. And so there'll be a couple of quiz questions on that, a couple of quiz questions to ask you to think about changes to supply and demand response, and then you'll be able to answer those just by looking in your spreadsheet subsidy model here. I guess one last thing to point out, let's just double the supply response in this model. And you get some bad results, right? So we end up with a very large quantity supplied and demanded. The producer price is now 60, the consumer price is -20, and the subsidy level is 80, and that just won't work, right? And so what we've done is we have a model here that is conditioned, or it's sort of built on the idea of an equilibrium price around 50, right? This basic price of around 50 and a target price of around 60. Okay, so it's trying to support producer prices at above the free market level, and it turns out changing from 1 to 2 is just too big of a change to this problem. You can see here that that we're now trying to support a price of 60. Sorry, we have the price floor is set at 60, but the free market price is only 33.33. That's just a huge change. So a way to refit this model might be to think about, what if the price floor level was something just a little bit larger than 33.3, maybe 35. can plug that in, and you see that you get a more normal result. If you want to be really, do something really complicated, you could actually set the price floor level here to be equal to some percentage increase from the free market price, right? I believe that would work out. So you could just set it to be like 1.1 times this free market price down here, and so it'll always be a 10% increase above what would happen in the market. So it actually works as an ad valorem subsidy, and so you should find commensurate results there. So there's a lot of flexibility here, and of course the fun or the easy part is once you build these two pieces, if you can accurately set up an A matrix and a B matrix, these coefficient matrices, then you have lots of flexibility to come over here and play with different scenarios in a market situation. So I'm going to set everything back the way it was. I want to save this. Save this, and this will be your model spreadsheet that you get. So there, anything you do to this from this point will be things you introduce. So you'll be given a couple of tasks in the quiz to go through, and that'll be our lab for this week.